Hello, so for this one, we're going to be creating an overlay. Like I mentioned before, I'm going to take an object-oriented approach to this. So this project is as modular as possible for different games. So for example, right now, we have the memory handler class, which handles all the reading, writing operations with our game. And then we have an interface class, or the offset handler, that handles all the game structures. So right now, we're going to be doing the same thing, but for the overlay. The overlay class will handle all operations regarding drawing and hooking input from the game. And then later on, we'll have a class built on top of that to handle all the menus or different tabs for the menu itself. I'm going to be using DirectX for drawing the overlay and ImGui for the actual menu. But if you wanted to, you could also use another GUI library like Conan, or just use DirectX directly to draw your own menu. I like using ImGui because it abstracts a lot of things that would otherwise make drawing an interactional menu a lot more complicated, like handling the user input, or just simple things like resizing the window would be really complicated to do just with DirectX. And it also makes drawing on that overlay window really simple. Alright, so let's actually make the class now. So I'm going to use add class so I don't have to do it manually. Let's call it overlay. Drag these two into the source. In here we're going to need a couple includes. We're going to need D3D11. I'm going to be using DirectX 11 because you should already have it installed for most people. And if you don't, it's as simple as just going to the Windows website, installing it, and then you should be able to use it directly after that without any further steps. If you have the option, you could use D3D12 or DirectX 12, which is a lot faster, but you could also use DirectX 9 if you don't have access to the newest Windows updates. It's not going to change much of the code, if at all. I'm also going to be using ImGui, but I'll show you how to install that manually in a second. wmapi.h. So this is going to have private. Let's set up the public and private. In the public members, we're obviously going to have the overlay constructor, and it's going to take a constant wchar d pointer to the window name, and we're going to have the deconstructor as well. We're going to have like 4 functions here. We're going to have the ToggleMenu. We're going to have void start render, void render, void EndRender, and void RenderLoop, which we're probably not going to use besides for testing. Now in the private members, we're going to have a window class. So that's going to be WND class XW WC. Now you might notice that for some of the barrels, I'm going to be using the ychar character version for initializing them. This makes it easier to integrate ychar characters later on. So if your game supports ychar characters like from some other languages, it makes it really easy for your window to actually draw them on the screen without any manual converting. So I highly recommend you always use a ychar characters for things like this, or the ychar versions. We're also going to have a handle to the window. We're just going to set it to null pointer by default here. And now we're going to have a couple DirectX 11 pointers. The first one's going to be the device, ID311 device pointer. Call it D3D device. Of course, if you were using other versions, you would use 11. I'm using 11, but if you're using 12, you would put 12 here, and I misspelled that. This is what DirectX uses for creating resources. We're going to set that to null pointer by default as well. We're going to have another one for the device context, which is used for rendering. I'll try to explain more as we go on. We actually use these. Now we're going to have another one, which is going to be the swap chain. This is what holds all the buffers that we're going to be drawing to. So think of it as a bunch of canvases. We have a canvas that's the one we're showing to the screen, and then we have a canvas on the back that we're drawing to be shown on the next frame. Usually we have 2 of those, where one is being shown to the screen, and the one behind it is being used to draw, set it to null pointer by default as well. And we're going to have the render target view, which is ID311 pointer. Now that's all we're going to have for members related to DirectX. We're going to have a couple other ones, or 2. The unsigned int for the actual window sizes. So resize width, unsigned int, resize height. Okay, so let's do the constructor first. That's probably going to be the most complicated, and then we'll do the rest. Before I show you how to do the constructor, let me show you how to install ImGui. So let me open the project folder real quick. Right click the project, open folder in File Explorer. Here it is. And I have another folder where I installed ImGui right here. Just copied directly from GitHub. You can either git clone it or just download it from there directly. I'm gonna go to source and make a new folder. I'll call it ImGui. In here, we're gonna need all the H files and the CPP files. So I'm just gonna copy all of these. Make sure I'm not missing any. And drag those in here. And we need some things from the backends. For this, we're gonna be using DirectX 11, so we need these two. And we also need the Windows 32 CPP and .h, since we're going to be making our own overlay. And that should be everything we need. You can close these right here, right click that, existing items, go to source, ImGui, just Control A to select all of them, and they should be all in here. All right, so now let's actually include what we need. So for this, we're going to need ImGui.h, of course. We're going to need Windows 32.h, or the implementation, or the backend for that. And we're going to need DirectX 11, since that's the version we're using. But if you were using DirectX 12, 11, 10, or 9, make sure you include the corresponding implementation for that. We're also going to have to include D-input, DirectX input, and we're also going to need D3D compiler.h, which you should already have with any of the DirectX installations. And we're also going to need the pragma lib comment. You can actually include the library, or those function definitions are stored. And make sure you don't misspell this, because otherwise you'll get a bunch of errors. And before we get to ahead, I'm going to go right here, go to the Windows 32.h, I think it's in here. And we're going to copy this line exactly, because later on we're going to have to make our own window proc to hook the user input from that overlay. I'm just going to paste that right there, so we have access to that function. Actually, let's declare that real quick, and then later on we'll finish defining it, just so we can use it in the constructor easily. So lresult WINAPI WND proc, our custom input handler for the window. So any user input that we send to the overlay will go through this function first. We'll check it, and then we'll send it to the original Windows input handler directly after. Of course, this is going to take HWND handle to the window itself. It's going to take unsigned int to the message, a W param for the type of message, and the L param for any data that's being passed manually. We'll have it empty for now. We do the construction, and we'll come back to this when we have an idea of what we're doing. So let's start with defining the window class, which is this. This is going to store all the things related to the window itself. So it's going to store size of the window and what function is being used to handle the input, which in this case is going to be our custom WND proc. Start off by initializing it to W. We're going to set the WCLP function, WND proc, to that function up here that we just declared. We're going to set the window name to the one we passed in, so that's LPCC. We're going to set the H instance to get module handle to null pointer, which just basically makes the parent of this window we're making to the process that we already started with the program itself. And we're going to register that window. I almost forgot. XW address of WC. We're going to create that window handle. Window handle is going to be equal to create window XW. Like I mentioned before, I'm using a wide chart character for almost everything, because that's going to make it really easy to integrate wide characters later on for when we're drawing the ESP. We're going to pass in some flags to this window we're making. The first one being WXEX layered. This flag is going to make it so it's layered, which means Windows will redraw it as soon as it can, unlike some other windows which it redraws every other frame. This makes it so we don't have any flickering when we're drawing the ESP or the menu. Then we're also going to have WSEX transparent. This flag doesn't actually make it transparent, it just makes it so your input is. We'll remove and add this flag later on, depending on if we actually want to draw the menu and if we want to take user input. But by default, we want to be transparent because the menu is disabled when we start off the program. And then we'll add the WSEX topmost, so it's also the topmost window and it draws on top of our game. There's an optional flag I'm going to add. It's going to be EX toolbox window, tool window. This is going to make it so the window doesn't have a toolbar icon. So if I didn't do this, we would have like a random icon here when we start it. Because I have this flag, it's not going to have an icon here at all. But you can still find it in Task Manager, and you should be able to find it here as well. It just won't have an icon in the toolbar. Then we're going to pass the window name. We're going to pass the window name again, because it's asking for the class name and the window name, and we're just going to set both to the same because it doesn't really matter. We're going to pass the style, which for now is just going to be WS popup. It doesn't really matter too much. For the X and Y, I'm going to do 0 because we want it to start at the top left. Now for the width and height, what I like to do is just draw the whole window. So it would just cover my whole screen. And then when I'm drawing the ESP, I just calculate where we should draw based on the window size and its location. Now some people might do something different where they use the X and Y to set it to the location of the window, and then change the width and height to also be the exact same size as the game window. I don't like to do that personally because it usually triggers a flag in anti-cheats. If you have an overlay that's exactly the size of the game and it also has the topmost flag and it has a window title that's suspicious, the game's going to think you're drawing something like an ESP. So usually I just do the whole window and just redraw based on its location instead. But it's just personal preference. So to get the window size, you get system metrics, CM, CX green, put a little space here so it doesn't go too far. We do the same thing for the Y, copy and paste that, CX green Y. Then we're going to pass in the parent. This handle doesn't have a parent, so we're going to pass null pointer since we're just making this window. It's not going to have a menu by default because we're going to make our own. The instance of the window is the one we just made back here. So I'm going to pass wc.hInstance, and it doesn't have any L params for now. So now we just made the window itself, and now we're going to give it some attributes. We're going to do set layered window attributes, which is this flag right here that we passed in, which makes it so it's drawn on every single frame and there's no flickering. Basically tells Windows that we're doing custom drawing on this and it needs to draw this as fast as possible. For the window attributes, we're going to make it transparent. So we're going to pass the window handle. We're going to set it to RGB 000255, which is the alpha value. And then we're going to have to pass two flags, which are WA alpha and WA color key. This is basically telling it that the last value of our RGB color is going to be the alpha, and we're also passing in a color. As we'll make it so the background of the window is going to be transparent. We're going to set the window position and with some flags. That's going to make it a bit easier to manage later on. Of course, we need the window handle. We're going to set it to handle topmost. We're going to set the X and Y to 0 and 0. We're going to copy this again, paste those two arguments. Then we're going to pass some flags, like we're going to pass SWP show window, which is going to make it so the window is shown when the overlay is constructed, or it's the active window. We're also going to pass SWP no size, there it is, which is going to make it so we don't have to resize it later on. It's going to ignore these parameters and it's just going to show the window basically. And SWP no move, because we don't need to move the window at the moment if it covers the whole screen. If you're doing it differently and you want to draw it right on top of the game, then you wouldn't have these parameters that I'm passing in right now. We're going to set a window pointer, which is basically a way of passing your own arguments to this function up here that handles all the input. And we'll pass GWLP user data, and we're going to pass in a pointer to this class itself. So in the function up here, we can access and call functions. So we can check the input, and if it's the ToggleMenu function, we can call the ToggleMenu function in the overlay class itself. For percuss, we have to change it to a long pointer to this. Now that will make it so here in our WND proc, we can have something like this where we set overlay. Now this is going to make it so we have access to class itself when we're dealing with the user input. Okay, let's go back here. Now we're going to have register a hotkey. This is going to make it so we can disable or enable the menu even though the window isn't active. We're going to pass in null because we don't care about the handle. We want it to be accepted no matter what window is active. So even if I'm playing the game right now, the overlay window isn't active, we can still register that hotkey. Our custom ID for that hotkey is going to be 1. We're going to have module no repeat, and we're going to have the actual key, which for my menu, I like BK delete, but you could have virtual key insert or some other popular one if you want. Now we're going to go ahead and declare or define these D3D11 devices so we can actually start drawing with DirectX 11. First, we're going to have to make a descriptor for the window that DirectX 11 is going to be using, and that's going to be a DXGI swap chain description. I'm going to call it SD, set it to default for now, and we're going to set a couple parameters. We're going to set the width of that place where this DirectX can draw to the same size as the window, which for now is the same as the system metrics. This is also one reason I like to just set it to the whole screen size, because if you were to move it along with the game, you would have to make a new description every single time, and you would lose a lot of optimizations. We need the same thing for the height as well. We're going to set the format to use RGBA, which is the one you're used to, and the one that ImGui uses. We're going to set the frame rate now. DirectX uses a weird way of doing it, which is by setting the numerator and the denominator of a fraction. So if we want to do 60 frames per second, we would have to set the numerator to 60 and the denominator to 1. So we do refresh rate numerator is equal to 60, and then we do the refresh rate denominator equal to 1. We're going to set the buffer usage, which is just going to say that we're drawing to this buffer. We're going to set the output window to that window we just made. We're going to set the count to 1 for the buffers we're using. We're going to set it to be windowed because we don't want it to be full screen and take all the input. We scroll down. We're going to have the buffer count as well to 1. And the swap effect is going to be to discard that buffer. Here we're setting the swap effect to discard because we don't care about the previous frame's contents. We just want to pump out frame after frame without caring or using that previous frame for anything else. Now we're going to set the feature level. We're going to be using, or I'm using, DirectX 11. So we want to tell the swap chain to use that version, because there's ways you can use maybe DirectX 11 for some buffers and DirectX 12 for some other buffers, so you can use different features. But we don't want to mess around with that. There's no need. We don't need that kind of level of optimization. So we just need to set it to DirectX 11 or the version you're using at the moment. And we're going to make a new constant to D3D feature level array. Set it to 1, and it's going to be equal to, and we're setting it to constant because the function requires constant. Feature level 11 0, and we're going to create a new buffer for that. D3D 11 create device and swap chain. So we're setting the device features and swap chains for drawing those buffers. This first argument, the adapter, we're going to set pass null pointer because we're not using that. For the driver type, we're going to use hardware. So we want it to be as optimized as possible. For the software, we're not doing any software drawing. We want the GPU to be used for this. For the color set, we want to go for the flags. We want to pass in the color set we're using, which is D3D11 create device, blue, green, red, alpha support. Do a little space here. Then we're going to pass the feature level array, the amount of buffers or feature levels, it's 1. The SDK version, we're just going to pass the constant D3D11 SDK version. For the descriptor, which we already made here, that describes the swap chain, we're going to pass the address of that, which is SD. For the actual swap chain, we're going to pass in the one we're constructing, which is this one. We can pass in that directly. It takes a double pointer, so we pass in the address of that, and that's going to take that address and update this address right here to the one that is constructing. It's going to be the same thing for the other one, the device. It's going to construct it for us. That's the device. It's going to need the feature level array, or it's going to need the feature level, and it's going to need the device context because it's going to create that for us as well. Now, if this fails, I'm just going to throw an exception and crash the program because I don't want to deal with, because it's a lot easier. I'm going to throw an exception, fail to create device in swap chain. We're going to need an include for the exception. So if you run into any errors, you know it's exactly this, something to do with DirectX. Now we're going to make those canvases that I was talking about. We're going to have 2 buffers because we don't really want to optimize that much. We're going to have the one that's being drawn and the one we're drawing to for the next frame. So it's going to be ID311 texture 2D pointer to the pointer to the back buffer equal to null pointer. We're going to use that swap chain we made in this function back here and add that buffer we declared. Get buffer 0, and the ID of that buffer we're adding is going to be IID PPV args, the address of that back buffer. And now we're going to create the only one we haven't created yet, which is the target view. That's what we're drawing to. D3D device, create render target view with that back buffer. The description doesn't really matter because we're just using default. And the thing we're constructing with the address of that is the D3D render target view we declared in our class. We're just basically telling the DirectX that we're using that buffer, and that's going to be our target for all our draw operations. Once we do that, we can then release that pointer to the back buffer. Okay, we've almost finished the hard part. Now we're just integrating ImGui with it. So this is pretty easy. Create context. I set the IO to void equals ImGui get IO void IO. And we're going to set some config flags. We're going to have, or what I like to have, this is all personal preference. This doesn't really matter for the menu. We're going to have the config flag that enables navigation with the keyboard. Now this depends mostly on how the game manages user input, but most of the time it works out of the box. We're going to have enable gamepad so we can also control the menu with our controllers. And we're also going to have another one that makes it so we use the in-game cursor. I like using the in-game cursor if they have a custom one, but if you want to switch to your cursor or to the Windows cursor whenever you hover over ImGui, then you can just not use this flag. I also like the dark theme for ImGui, so I'm going to use that. Style colors dark. Then we're going to initialize ImGui with DirectX and Windows 32 window handle we made. So ImGui implementation Win32 init with that window handle, and we're going to do the same thing for DirectX as well. Instead, this is going to take the D3D device we made and the device context, so it knows what context to use for it to input. And we're going to force the window to be shown. Show window, window handle, and SW show. Okay, everything looks good. Now we just have to actually render it and deconstruct it properly. Let's do this real quick just to make sure when you close the program you don't run into any issues with the overlay staying turned on or still drawing. We're gonna first call the implementations of ImGui to shut down. We also want to shut down the Windows 32 context that's for ImGui, and we want to destroy the context for the user input. After that, we can start releasing those pointers to those descriptors here and devices to DirectX. So we're going to release all of them. Just do that real quick. Once we release all those DirectX devices and descriptors, we're going to destroy the window using the window handle that we made. And then we're going to unregister the class. It's going to take the class name, which is the same as the window name in our constructor, lpzs class name, and wc.h instance for the parent of that class we're unregistering from. Let's go back here. What do we need? We need ToggleMenu. Let's do ToggleMenu real quick. Should be pretty simple. First, we're going to show menu is equal to not show menu. I don't know if I actually declared that in our overlay. I did not. So let's make a new private bool show menu. By default, let's set it to false. For debugging, I'm going to have stdc out that we toggle the menu. With our current configuration, we'll both have a console and the overlay, but later on we can remove the console through the project settings. And make sure you include that IO stream, so we don't have any errors. Now we're going to have to change the window flags depending on if the menu is enabled or disabled. So like I mentioned before, transparent makes it so the input goes through. So if the menu is enabled, we want this flag to be off so we can actually interact with the menu. When the menu is not being shown, we want this to be transparent so we can still interact with the game underneath. Because of that, we're going to have to get the current styles. So long style is equal to get window long, so we can get the current flags of the window handle, and GWL X style. If show menu, we're going to disable it being transparent so we can actually interact with the menu. So we and equals the not of WSEX transparent, else we enable that transparent flag again. So it's or equals, which is the same thing we're doing here when we're passing in a flag, we're using or WSEX transparent. And now we're going to set the style to reflect that. Window handle, GWLEX style, and the style we just made. And now we're going to copy what we have up here. Set window, this one, set window layered window attributes. Now this isn't really going to do anything. It just forces the window to update its attributes. Sometimes if you don't force it, it'll take a couple frames or a couple seconds to update its styles, and that could be really annoying when you're trying to interact with the menu fast. Alright, so now let's define these render functions, and then we'll finish off with the WinDproc, and that should probably be it. So for the start render, it's pretty simple. We're going to start a new ImGui implementation, DX11 new frame. We're going to start a new Windows 32 new frame, ImGui as well, and then we're going to do ImGui new frame. Now we're going to clear the colors on the DirectX 11 device. Clear color, set it to 4 because we're using 4 colors, that red, green, blue, and the alpha. So 0, 0, 0, 0. Now we're going to clear the device with those colors. So clear render target view, D3, 3, render target view, and that color we just made. We do the other one, render is a bit more. In render, we're just going to show the menu for now, but later on, we'll have all the other functions like drawing the ESP and any other visuals will go in this function. So if show menu for now is all we're going to have. Let me do a test. ImGui button with CDC out so we can test that everything works correctly with the user input. Show menu. So if ImGui button to A, we're going to std cout A. And make sure you always end your ImGui calls, because otherwise you'll run into input issues. ImGui won't know when the menu starts and it opens, so it won't be able to handle the user input correctly. Okay, let's do this now. So the first thing we're going to do is let ImGui handle all of the messages it can, and then we're going to handle the messages it doesn't. So we're going to use this, and we're just going to pass in the same arguments that we have up here. So we have the handle, the message, the W param, and the L param. The message is the type of key that was received, or the message identifier, and then these two other parameters are just additional message information that varies depending on the message that was received. So if ImGui manages that message, we don't have to deal with it at all, and we're just gonna return true. So basically returning true says we're done processing this message, and returning 0 or false would mean we're not processing the message at all. So there are other messages we can return, which I'll get into in a second when we use the default Windows proc handler. But there's a few messages we have to handle ourselves just to make sure we can interact with our menu. So the first one we're going to handle ourselves is the case of in test, which basically tests whether our mouse is over the overlay or not, or the menu. So this will ensure that the window recognizes our mouse interactions and it doesn't go through. So if we click the button in the menu, it recognizes that we clicked the button and it doesn't feed that to the window behind it. So let's do a case, and it's going to be WMNG. So if overlay is turned on, or if our overlay is valid, just in case we run into any runtime errors, and the overlay is menu shown, which will need a function for that. Let's do as menu visible instead. We're going to return the HT client, which just says that the cursor is over the menu, and we shouldn't send any of that information to the client underneath or any other windows underneath, and we can just break. We're gonna have another case for any the WM sys commands. This handles any commands related to like alt tabbing or alt F4, commands like that. And we want to check a very specific command, which is the alt. Normally when you click alt, it goes to the top. Like if you click right, it goes up here. We don't want that to happen to our menu. We want it to stay focused on the window, even if we press alt. We'll still be able to alt tab any other command. It's just so the focus doesn't get messed up if we press any other commands like the show tab button or the show toolbar button. It's not necessary, but I think it's nice. So if wparam and 0xff0 is equal to sc key menu, return 0. Otherwise, we just break. And this should be a 0 instead of a no. Okay. The next case, we want to handle any WM destroys, just so we can close the menu properly. So if we get the WM destroy function, which is either clicking the X or doing Alt F4 or right clicking down here, then you would be able to handle that accordingly. So if we get that destroy message, we're just gonna post quit message so we can close out of the DirectX correctly and go into the deconstructor of this class and close the window handle correctly, and return 0 because we're done pre-processing, and quit message is 0 here. Now that everything has been handled that needs to be handled by us, we're going to let everything else be handled by Windows. We do that by just returning : proc w, which is the default Windows message handler. I'm going to pass the same exact arguments, which are the handle, the message, w parameters, and the L parameters. And let me define that real quick before I forget. Rule is menu. Okay, let's do EndRender, and we can do the RenderLoop, and we should be able to test our menu. So EndRender should be pretty simple. We're going to call, of course, ImGui render first. Update that device context with our new drawings. So ID2D device context. OM set render targets. The number of views is just 1. The render target view is the one we've already defined in our class header, which is the D3D render target view. And the stencil view, the depth of that doesn't really matter, so we can just pass in or no pointer. Now we're going to call it the ImGui implementation to also manage and draw that render draw data in ImGui. All we're missing is the render loop, and if we do everything right, we should have a working overlay. So this render loop is, for now, it's just going to be for testing. Later on, in the interface class that manages this, we'll do this instead. But for now, we'll use this. First, we'll make a new message that will store all messages, like quit messages, hotkey messages, the same type of messages that we saw back here. They're just named a bit different. We're going to 0 the memory just to make sure we actually have a default message and not just a random one. Okay, so now we're actually going to handle all the messages. So first, we're going to check that the current message that we have is an quit message. Of course, the first message that it gets is not going to be the quit message, so we don't have to read it for now. But subsequent while loop iterations, it's going to have a message to check over. So while it's not equal to WM quit, I'm going to run this loop. This message that we're checking for here is the same message we're sending right here if the case is WM destroy. Okay, so now we're going to peek the message. So if peek message, so address a message, then it takes null pointer because we don't really care about the handle. You can have pass 0, 0, and PM remove because after we read it, we don't really need it. So now if we have a message that's a WM hotkey message, so if message.message is equal to WM hotkey, we're going to go into this other if statement. And now we're going to check if that hotkey is the custom one we just made. So we go back up here. We registered a hotkey with an ID of 1 and the key being vk delete. So now all we have to check is if message ID or the W param in this case is equal to 1, then that's our custom hotkey. If we press that, we're going to toggle the menu. After all of that, we're going to translate the message and dispatch the message so Windows can actually deal with it. Then we can just call our render functions that we already made. Start render, 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 and end render. So like I mentioned before, we have 2 canvases. So now we want to swap the buffer that we just drew to and the one we're drawing to so we can display the updated buffer. So now we just want to set and actually present that drawing. So we call D3D swap chain present 1 and 0. And unless we're missing anything, we should be able to test. Do we have everything set here? Perfect. We go to main and actually try that out. We don't need any of this for now. We can include our overlay.h. We want to overlay, and the name is going to be overlay. One thing you don't watch out for is that you don't put things like cheat or any words like that that could indicate that it's a cheat or a hack or something like that, because anti-cheat will read all the menu names, and if they see something suspicious like this, they will flag you as suspicious. So make sure your overlay name isn't anything too crazy, and we can just call the RenderLoop now. And now we should have a nice menu. We did it correctly. There's no menu being shown. I press delete. It's a little bit small, but I should be able to resize it. There we go. Works. I click on it, nothing happens in the background. It stays topmost even when it's enabled. The input goes through. If I press delete, the menu is disabled. And as you can see, even though my key is delete, it's not deleting this like I just did with backspace. So it's not sending the input through if it detects a delete key. And our button is being toggled correctly. If I close this, it just disables the menu through show menu. And that's probably going to be it for this one. You should be able to work off of this for now, but for next video, I'll probably have an empty-to list, hopefully. And from there, we can actually start doing an ESP or some other visuals after that. But anyways, thanks for watching, and peace.